Good morning. Today we're going to be talking about angles. This will be the first topic in the second half of our Unit 3. And so here we go. The first kind of angles we're going to talk about are complementary angles. And if we look at these here, we're going to look at the measures of those angles and see what we can discover about complementary angles. And you may have studied complementary angles before, so this may be a little bit of a review for you, but it's just to get our brain going again. So we have 27 and 63. Those angles, since they're not side by side, they're separated there. They're actually called non-adjacent angles. And if we look at 27 plus 63 and we add those together, we find that 27 plus 63 is 90. 27 degrees plus 63 degrees is 90 degrees. And these are complementary angles. So let's see if that relationship continues to hold true. We will look at the 42 and 48. If we add those together, we see that those are 90 degrees. That does happen to be the definition of complementary angles. And again, the 42 and 48, those are non-adjacent. If we look at the next one with the 75 and the x there, we can see that those two angles together, they share a side. They're called adjacent angles. And we can see that that angle, the total angle there is 90 degrees. It makes a right angle. So 75 plus x here is also 90 degrees, and those are complementary angles. Some people remember complementary because if you put them together, they make a corner. And then if we look down at the last one that has the A and the B, angle A plus angle B is 90 degrees, and these are called adjacent complementary angles. Again, the two sets on the left are called non-adjacent. The ones on the right are called adjacent. And let's look at some examples of how we can use these. Here, if we want to solve for x and y, first of all, we see that ABCD is a rectangle, and we know that rectangles have 90-degree angles. So x plus 65 up there, those are adjacent complementary angles. And we know that x plus 65 has to equal 90. And in order to solve for x, we're going to subtract 65 from both sides. Our 65s on the left-hand side will cancel. And when we simplify, we're left with x equals 25. We're going to do something very similar. On the right-hand side, we have y and 25 there as the measures of those angles. We know that the angle of a rectangle is 90 degrees, so 25 plus y is 90. To solve for this, we're going to subtract the 25 from both sides. On the left-hand side, the 25s will cancel, and then when we simplify, we have y equals 65. All right, let's move on and look at another type of angle now. We're going to look at supplementary angles. So here, if we look 60 and 120, those are non-adjacent supplementary angles. And when we add those together, instead of getting 90, we now get 180. And we'll look at our next pair. We have the 45 and the 135, and those are also supplementary angles. And we notice when we add those together, we get 180. And so that would lead us to believe that supplementary angles sum to 180, and indeed they do. That's the definition of supplementary angles. The 45 and the 135, those are adjacent supplementary angles. And when you have adjacent supplementary angles, they're also something that we call a linear pair. Because the lines that they do not share in common make a straight line, or the sides that they do not have in common make a straight line. And that makes a linear pair very easy to spot as a supplementary angle. Those are also sometimes called a straight angle because they go across and make a straight line. Supplementary angles. Here we have x plus 38 would equal 180 degrees, and that would allow us to solve for x. And then finally, just defining the relationship in terms of variables. A plus B equals 180 when we know that those angles are supplementary. And again, we don't have to be told they're supplementary if we can see that they share a side in common, and the sides that they do not have in common make a straight angle. If there's non-adjacent supplementary angles, they're separated, like in the first example we had. If one of those angles was missing, we would have to be told that those two angles are supplementary in order to solve for the other. But in the cases where they're adjacent like this, we don't have to be told that because we can see that the sides they do not share make a straight line. All right, so let's use these supplementary angles. Here, again, they're adjacent. The sides that they do not share make a straight line. So I know that x plus 130 must equal 180, and I'm going to subtract 130 from both sides. Then when I cancel on the left-hand side, that 130, I get, and simplify, I get x equals 50. And then on the right-hand side over here, with the y and the 77, I know that y plus 77 is 180. I'm going to subtract my 77 from both sides. When I cancel the 77s on the left-hand side, and then I'm going to simplify, and I get y equals 103. All right, let's look at vertical angles. And in the first picture there with the F, G, H, I, and E, E is in the center, and it is the vertex of every one of those angles, and there are 4 angles created around there. And the 2 smaller angles are the 46-degree angles, and they are considered vertical angles, and they are congruent. They have the same measure. And the 2 larger angles, they are also vertical angles because they share that vertex, that point in common. And they're 134 degrees in this case. So vertical angles have the same measures. So here, if I look at A and B are equal to each other because they are vertical angles. And we can use that relationship down there in the final example with the 3x plus 20 and the 10x minus 15 we could actually solve those for x because we have 3x plus 20 equals 10x minus 15. We have an equation, we have variables on both sides, but we could solve that, and we will solve some of those momentarily. But the big idea to take away from this is that vertical angles share a vertex. They're kind of the angles that are sort of opposite each other if you look at those pictures, and they are always equal in measure. So if you know what the measure of one angle, you also know that the vertical angle that matches that angle has the same measure. All right, here we're going to solve for x, and in the first example we have 74 degrees and 2x degrees. So we know that 74 must equal 2x because those 2 angles are vertical. So 74 equals 2x. I'm going to divide both sides by 2, and then when I simplify, I have 37 equals x. And then on the right-hand side, I have 3x plus 20 and 10x minus 15. Those 2 equations are equal, or those 2 expressions are equal, I'm sorry. So we can make our equation. And then we're going to subtract the 10x from both sides because I want to get my variables on the same side. And 3x minus 10x on the left-hand side is going to give me negative 7x. The 10x's on the right-hand side are going to cancel. And so when I simplify, I have negative 7x plus 20 equals negative 15. Now I'm going to move the 20, so I'm going to subtract 20 from both sides. The 20s on the left-hand side make a 0, so they cancel. And when I simplify, I have negative 7x equals negative 35. And then I'm going to divide by negative 7, and I have x equals 5. All right. Those are some ways we can use vertical angles to solve, and you will be using those to set up equations, solve for variables. Even in this case, we could plug the 5 back in, and we could find the measure of one of those angles. If we look at 3x plus 20, if we put 5 in place of x, we have 3 times 5 is 15, plus 20 is 35. And if we substitute on the other side, 10 times 5 is 50, and 50 minus 15 is 35. Those 2 things are equal for that value of x, as they should be because they're vertical angles. All right, so let's review. We have complementary angles, and complementary angles add to 90 degrees. There are 2 angles that when you add them together, they're equal to 90 degrees. Supplementary angles, they add to 180 degrees. They can be adjacent, non-adjacent. Complementary angles can be adjacent or non-adjacent. Adjacent just means that they share a side in common. Non-adjacent, they're separated. All right, vertical angles have equal measures, and they also share a vertex. Adjacent angles are angles that share a common side, and a linear pair, remember, are just adjacent supplementary angles. So when they share a common side, and the sides that they don't share make a straight line. So let's identify each of these here. In the first pair, where the 27 and the 63 is, of course, those are non-adjacent because they're not sharing a side. And if I look and I say 27 plus 63, I add those together, they equal 90. And so those are non-adjacent complementary angles. When I look at the next example, I have the 45 and the 135. I can see that those are adjacent because they share a side. 45 plus 135 is 180. So those are adjacent supplementary angles, but they're also a linear pair. And it's important to note that both terms can be used there. And then in the next example on the bottom left-hand side there, I have the two angles that are opposite each other marked, and they are sharing a common vertex. So those are vertical angles. And then on the bottom right with the A, B, C, and D and the angles 1 and 2, I can see that angles 1 and 2, they don't make a right angle. The sides they don't share don't make a straight line. They do share a side, so they are adjacent angles, but that is as much as I can say about those. They're neither supplementary or complementary based on the diagram, and sometimes adjacent is as much as we can say. So we're going to have some problems throughout this unit practicing these different relationships. I hope you took good notes so you have this to refer to.